This is the 12.3 vector physics lesson. In this unit deals with the concept of vectors and the notation of using vectors as I, J, and K as your three-dimension vector. With this format, many times used for physics, which you have your distance equation, velocity equation, acceleration, and speed. These are the four main concepts that we'll be dealing with this main equation. So taking the derivative of the distance will, of course, give you the velocity. And to take that, you take your equation relative to time, x, y, and z, relating in the three-dimension directions, and taking the derivative of each term separately, and that'll give you the velocity of each separate term. Adding them all together will give you the velocity. Doing the same thing, so the double derivative will give you the acceleration of each three terms. And then for the speed, you take the magnitude of your velocity line. So it's going to be the square root of the derivative of x, y, and z squared, and the square root of that. And that will give you the speed. Giving you, of course, a function of t, most likely. So starting off, we're given an acceleration vector tj plus tk using your equations y and z. So to start off, we know that we'll have to take this equation and take the integral once to get the velocity, again to get the distance equation, then go back to our velocity equation, take the square root of each term squared to get our speed equation. So, and these are our initial conditions that we'll use to solve for the unknown constant c that we'll get in our integral. So starting off, we need to solve for the velocity of t. So the velocity of t, as we know, is taking the integral of our acceleration. The integral of tj plus tk dt. And that'll, of course, be t squared over 2j plus t squared over 2k plus our constant c. And to get that constant c, we know that v1 up here equals 5j. So, solving for that, we know that 5j equals our 5j here equals this. So solving for c, we throw equations around, do algebra, and we get 9 over 2j minus 1/2 k. And that's our constant c that we can throw in there. And that'll give us, back to our velocity equation, which has to be, combine the terms, 2 minus 9 over 2j. That'll be a plus instead. Then plus t squared over 2 minus 1/2 k. And that's our velocity using our initial condition, v1 equals 5j. So then we take the integral again. So to get our distance, that's going to be t squared over 2 plus 9 over j plus t squared over 2 all respect to dt. And then we know that that'll have to be d cubed over 6 plus 9 over 2 t. That's j plus t cubed over 6 minus 1/2 t, or t, and that's k, plus our constant c. And then we know that r1, of course, has to be 0. So with that in mind, we set r1, so that's going to be 0 here, 0 here. We know that c has to be negative 14 over 3 j plus 1/3 k. And then we have plus 9 over 2t minus 14 over 3. That's our j vector plus our k, which has to come out as k. And that's our position vector here. And ran out of room, but if we were to do speed here, we know that we would take the magnitude of our final velocity vector, and we would take the square root of this squared plus this squared. That will give us the equation for our speed.